NASA's recent press briefing drew significant global attention, not only because of the scientific value of the new data being presented, but also because of the swirl of rumors that had grown online regarding the mysterious interstellar object known as Comet 3 I/Atlas. At the very beginning of the briefing, NASA Associate Administrator Amit Kshatriya chose to address the speculation directly, aiming to bring clarity to a subject that had triggered both scientific excitement and public curiosity. He spoke calmly but firmly as he emphasized that NASA's assessment of the object was guided strictly by evidence gathered across multiple spacecraft and observatories. "I'd like to address the rumors right at the beginning," he said, acknowledging how quickly public speculation had escalated given the comet's unusual characteristics and the long communication gap caused by the government shutdown. "This object is a comet. It looks and behaves like a comet, and all evidence points to it being a comet. But this one came from outside of the solar system, which makes it fascinating, exciting, and scientifically important." His statement served as a reminder that while the comet's properties were extraordinary, they did not necessarily justify exotic or artificial interpretations. Comet 3 I/Atlas first entered the scientific spotlight on July 1st, when it was discovered by the Asteroid Terrestrial Impact Last Alert System, commonly known by the acronym ATLAS. This detection system is designed to spot near-Earth objects that could potentially pose a threat, but in this case, it identified something far rarer: a visitor from interstellar space. Such discoveries are exceptionally uncommon, with only 2 confirmed interstellar objects before it, making this the third in recorded history. Its initial observations provided limited information, but even the early data hinted that this object was unlike typical comets born within the solar system. Its speed, trajectory, and bright coma suggested it had originated from somewhere far beyond the Oort cloud, traveling for millions, perhaps billions, of years before passing through our region of space. The best images of the comet obtained prior to NASA's latest release came from the Hubble Space Telescope on July 21st. Hubble's powerful optics captured a faint but distinct view of the comet's structure, revealing a diffuse tail and a surprisingly symmetrical coma for an interstellar traveler. Scientists found this particularly intriguing because objects entering the solar system from interstellar space often undergo intense thermal and gravitational stress, which can fragment or distort them. Yet 3 I/Atlas appeared relatively intact, which later contributed to speculation about its structural resilience and the possibility that it behaved differently from typical comets. During the extended 43-day U.S. federal government shutdown, which halted many NASA operations and communications, the comet continued its journey unobserved by the public. This period of silence fueled online curiosity, especially after it was revealed that the comet made its closest approach to the Sun on October 29th, while the shutdown was still in effect. Only after the government reopened on November 12th was NASA finally able to process, assemble, and publish the extensive collection of data it had obtained from various spacecraft. The delay unintentionally created an information vacuum that conspiracy theorists filled with claims of artificial origins, secret missions, or extraterrestrial engineering. NASA's eventual release, however, offered no evidence supporting such ideas, presenting instead a detailed scientific portrait of a natural interstellar comet. Among the most striking elements of NASA's newly unveiled data were several previously unseen observations from multiple spacecraft positioned throughout the inner solar system. These instruments had the advantage of being located in places where ground-based telescopes could not observe the comet, providing unique angles and ultraviolet, visible, and infrared data that together painted a much more comprehensive picture of 3 I/Atlas. One of the most notable observations was an ultraviolet composite captured by an instrument aboard the MAVEN orbiter on September 28th. MAVEN, which is usually dedicated to studying the Martian atmosphere, happened to be in an ideal position to observe the comet's hydrogen cloud just days before its closest pass by Mars. The ultraviolet imagery highlighted the massive halo of hydrogen surrounding the comet, created by the breakdown of water vapor as it interacted with solar radiation. This hydrogen cloud extended far beyond the visible coma and provided important clues about the comet's composition and activity level as it heated near the Sun. Another rare observation came from NASA's Perseverance rover on Mars. The rover's MAST-CAMZ instrument captured two faint images of the comet as a subtle smudge against the Martian sky, taken while Perseverance continued its scientific operations along the rim of Jezero crater. The comet at that time was roughly 18.6 million miles away, far too distant to appear clearly, yet close enough for the rover's sensitive optics to detect a slight enhancement in brightness. This marked one of the very few times a Mars-based instrument has imaged an interstellar object, adding a unique data point to the collection of perspectives captured across the solar system. NASA's Psyche mission, currently en route to the metallic asteroid Psyche, also contributed valuable data. Over a span of 8 hours on September 8th and 9th, the spacecraft recorded 4 separate observations of the comet from a distance of about 33 million miles. Psyche's instruments were able to track the comet's brightness fluctuations and subtle changes in its coma structure, helping scientists model the rate at which the comet was releasing gas and dust. These observations were particularly important because they were collected far from Earth's line of sight and at a time when the comet's illumination angle differed significantly from earlier views. This offered scientists a richer three-dimensional understanding of its behavior. Despite the scientific significance of these observations, public fascination with the comet continues to center on its more unusual attributes. In particular, the object's remarkably high nickel-to-iron ratio has drawn attention, as such compositions are rare among known comets. Additionally, its structural integrity, its ability to remain intact despite its interstellar journey, and its close passage near the Sun, has led to speculation that the object might not be entirely natural. These factors, along with its sharply defined interstellar trajectory, encourage some researchers, including Harvard astrophysicist Avi Loeb, to explore whether the possibility of a technological artifact should at least be considered. Loeb has been known for his openness to investigating non-natural explanations for interstellar anomalies, particularly after his controversial proposal regarding the earlier object Oumuamua. However, NASA and the broader scientific community maintain that extraordinary claims require extraordinary evidence, and so far, all credible data supports the classification of 3I/Atlas as a natural comet. The unusual nickel-iron ratio, while interesting, could indicate that the comet originated in a planetary system with different chemical abundances than our own. Its structural integrity might simply reflect a denser or less porous internal makeup than typical solar system comets. And its interstellar pathway, while unusual, is entirely consistent with the gravitational scattering that occurs in young planetary systems, where forming planets can easily eject icy objects into interstellar space. These explanations, grounded in astrophysical principles, do not require invoking artificial design or technology. NASA's decision to address the rumors openly, paired with the comprehensive release of spacecraft data, reflects an effort to maintain transparency and scientific clarity in an environment where misinformation spreads rapidly. The interstellar origin of Comet 3I/Atlas is indeed rare and fascinating, and its characteristics present new puzzles that researchers will continue to investigate. But NASA's stance remains that the comet fits within the spectrum of natural cosmic phenomena, remarkable, but not unprecedented in a universe filled with billions of planetary systems. The data now available will help scientists refine models of interstellar comet behavior, understand the diversity of materials formed around distant stars, and gain insight into how objects like this travel across unimaginable distances before briefly passing through our celestial neighborhood. In the months and years to come, as analysis continues and more telescopes and spacecraft contribute observations, Comet 3I/Atlas will likely remain a symbol of both scientific wonder and the importance of distinguishing evidence from speculation.